Welcome to the fourth video in the Metric Math Water Wastewater video series. This video is going to focus on how to check if you're using the formula correctly. Are you multiplying when you should be dividing, or are you doing the right thing? It'll even help you make up your own formulas if none is available to you. We're going to have a number of sample problems for us to work through, and hopefully this will clarify or help you when you're doing some math formulas that you're just not that familiar with. Okay, when we're talking about unit cancellation, this may seem like a kind of a stupid thing, like why are we putting all these units in? It's just a waste of time. But I can't think of a better way than unit cancellation to check if your math is being done correct. If the units work out, your math is correct. Now, are you actually doing the right formula? Are you multiplying when you are supposed to be multiplying, or should you be dividing? All of those questions are answered if you follow the rules that are specified in this video. Now, whenever you are converting something to something else, there has to be a conversion unit that's reversible. You know, how many grams to a kilogram? Well, it's not just converting grams to kilograms. You can reverse that to go how many kilograms converted to grams. So that's just classic. For example, if you have 1 meter of head pressure, that's equal to 9.8 kilopascals of pressure. Now, there's a number of different ways to write that. It could be 9.8 kilopascals per meter of head, or it could be 1 meter of head per 9.8 kilopascals. Either one of those is correct, depending on what you're given. If you're giving meters of head, then the first example. If you're given kilopascals, then the second example is given. So those are all classic examples. Another one is if 1 horsepower is equal to 0.746 kilowatts, then that equation, or that conversion unit, is 1 horsepower per 0.746 kilowatts, or 0.746 kilowatts per 1 horsepower. So those are all equal. So where are we going with this? Well, another thing that you have to keep in mind, every number except pi must have a unit. There's just no exception to that rule. And whenever you're converting units from one to another, make sure that the units cancel out. If the units cancel out, then you're doing it right. Just check all the time. If they're not canceling out, then it doesn't matter how many times you're going to do it, you're doing it wrong. So stop, regroup, look for your error, and then at that point in time, you're going to save yourself a bunch of time and frustration. So, first of all, whenever you're given a problem, first thing you have to do is identify what unit is given to you and where do you have to end up. For example, what's the pressure in kilopascals at the bottom of a 15.5 meter high column of water? So here you are given your starting unit. It's a measurement. You know what it is. It's meters. It's not just random number of meters. It's been measured at 15.5 meters. The ending unit is attached to a question. What is the pressure? And notice they then tell you what your ending unit is. Now, once you have found your starting and your ending units, then there's got to be a conversion in there someplace for you to solve the question. If there's no conversion, you can't do it. So we've established already that 1 meter of head is equal to 9.8 kilopascals. We've also established it could be written as 9.8 kilopascals per meter, or 1 meter per 9.8 kilopascals. Which one of these are we going to use? That becomes the question. So once again we've established our starting unit, our ending unit, and the conversion, now we put the conversion into the formula so that it will be able to help us get the solution. So first of all, we know our starting unit is meters. We know our ending unit is kilopascals, and there's going to be something in the middle. Now, which one of these two do we use? Now, the key rule is whatever unit you start off with, in this case meter, that unit has to disappear. And the only way you can disappear, the only way you can make it disappear is to have it in the bottom of the formula. So notice in this first one, you will notice that the meter is in the bottom. 5 divided by 5 is 5. 20 divided by 20 is 1. All those numbers work out to 1 if they divide by themselves. So if you take a look at this one, if you can get rid, or if you want to get rid of that starting unit, that unit has to be in the bottom. The ending unit has to be on the top. And in this case, we want kilopascals to be on the top, so we use the first conversion option. Now that we have identified what our starting unit, what our ending unit is, what the conversion is, now we can set it up. And just to confirm, the final unit is at the top, the starting unit is in the bottom. So this is a confirmation. We want to double check to make sure that we're doing this right. So our starting unit is meters, 15.5 meters, and we multiply by 9.8 kilopascals for each meter. And you'll notice how, oh, look at that, magically, the meters cancels out, and the kilopascals is left as our final unit. And you'll notice that there's an equal sign in there. The equal sign means it's the same thing. So kilopascals is on the left side, kilopascals is on the right side. They are equal. That's the unit that we want. Oh, look at that. We are doing this correct. So that's our first big idea that you have to take a look at. Another example, a motor is rated at 15 kilowatts. How many horsepower would this motor be rated at? So you're given a number in kilowatts, but you want to convert that to horsepower. So first thing you look at, what's the important information? 15 kilowatts. What are we trying to find? Remember, the unknown is usually associated with a question. How many? What is? There's a question in there. So how many horsepower? So now we know that we're going to use the horsepower and kilowatt conversion. Now, from a set of tables you have to have either memorized or available to you, you should know that 1 horsepower equals 0.746 kilowatts. So that's equal. So you set this up in a fraction. That's equal to 0.746 kilowatts for each horsepower, or per 1 horsepower, or 1 horsepower per 0.746. So now we have our starting unit, we have our ending unit, and we have our conversion. So now we can start putting these in. So 15 kilowatts is our starting unit, our ending unit is horsepower, and our conversion, notice, has to have the kilowatts in the bottom because we want to get rid of it. And the ending unit has to be on the top so that horsepower equals horsepower. So now we've got the correct starting point, we've got the correct ending point, we've got the correct conversion unit, and now we are ready to do the actual math. And when you put these in, notice the kilowatts are going to cancel out. The horsepower is equal on both sides. So we know that we are doing the right formula. And again, the biggest problem that people have is they just intuitively just jump right ahead and they go straight to this part, and sometimes they multiply when they should have divided. And in this case, this is a pretty common problem with this exact problem. They multiply instead of dividing, and you get the wrong answer. In this case, the answer should be 20.11 horsepower. Another one, plant uses 15.8 kilograms to form a dosage of 3.75 milligrams per liter. And notice, what's our starting unit? Kilograms. What's our final unit? Well, it's got to be in megaliters. And notice we have a conversion unit that's in there. And in the previous videos, you identified that 3.75 milligrams per liter is the same thing as 3.75 kilograms per megaliter, but it can be flipped around, or 1 megaliter per 3.75 kilograms, either one. So we've identified our starting unit, we've identified our final unit, we've identified our conversion, And that conversion in milligrams per liter is the same thing as 3.75 kilograms per megaliter. Now that you've identified those, now you just have to plug them into your formula. Starting unit is right at the beginning. And notice that's going to have to go on the bottom of our conversion. The ending unit has to be on the top. Once those are put in, now you can see that we have our formula is going to work out. Kilograms cancel out. Megaliters equals megaliters. The units cancel out. We haven't even put any numbers in yet. That will come. Don't worry about that. If the units cancel out, then the math will follow. So now you just put the numbers in, 15.8 kilograms. Notice it's divided by 3.75 kilograms for each megaliter, and your answer will come very, very quickly. So again, be patient. Biggest problem that people have is they rush it. So in this case, you're dividing. Notice how the kilograms cancel out. Notice how the megaliters is the same on both sides, so it must be you're doing it right. And then your answer is going to be 4.21 megaliters. How many seconds are in 4.5 days? Now, we looked at earlier how many seconds in a day, but this one kind of speeds things up, takes it a little bit further. So, what are our starting units? Days. What do we have to look for? Well, seconds. Once we've established that, is there some sort of a conversion that we can use? Well, we're starting with days. And again, we don't even put 4.5 in. Don't even worry about that yet. We end up with seconds. Now, if you know that there is a straight second conversion, well, then fine. But if you don't, you might have to go step by step. So we know that we got to get rid of that day, so it has to go on the bottom. Cancels out. Now we're left with hours. The conversion from hours to minutes, they cancel out. And then we're not at the correct final unit. Now we're at the correct final unit when the minutes cancels out, and we should be good to go. Seconds equals seconds. We know that we're doing this right. So now put the numbers in. Okay, the setup is correct. Now you can put the numbers in. 4.5 days multiplied by 24 hours per day. And notice we no longer have days. Now it's how many hours? 4.5 times 24. And if you would stop it right there, you would have a number on your calculator. But we're not at the right point. Take that and multiply it by 60 minutes. Notice how the hours cancel out. And now we're at number of minutes, but that's not the right final unit. Multiply that by 60 seconds, and you're at the correct unit. Now, some of you have already in previous videos found out that there's 86,400 seconds per day. Well, great. If you know that shortcut, you could have just put 4.5 days multiplied by 86,400 seconds in one day. And that'll would save you some time. But I just put this one in there so you can see individual steps. Here, in this scenario, there's roughly about 388,400 seconds. So, summary. What are we dealing now with our summary? First of all, identify your starting unit. What's your final unit? And what conversions do you use? And remember, when you're looking at conversions, you just have to find them. Once you've found the conversion, then take a look at the starting unit has to be in the bottom of your conversion unit. Your ending unit has to be in the top. Once that's set up and you've flipped it around the correct way, then cancel the units to make sure that you get what you need. Once the units all work out, put the numbers in and then solve and check to make sure that the units all work out. Thanks for watching this math video. I invite you to please check out the other videos in this series. Put in some comments, really appreciate that, and then pass it on to anyone else that you feel would benefit from it. Goodbye for now, and have a good day.